Welcome back to new module. So we'll be looking through module 4 knowledge check for Amazon Web Services Solution Architect Associate. So let's start the knowledge check. So let's start with question number 1. Which attributes are the reason to choose Amazon Elastic Compute Cloud Amazon EC2? So it should be like, let's go through this answer. Ability to run any type of workload, ability to run serverless application, Amazon Web Services management of operating system patches, AWS management of operating system security, complete control of computing resources. So I think the answer is the first and the last. What are the benefits of using an Amazon Machine Image AMI? Migrating data from on-premise to Amazon EC2 instances, selling or sharing software solution packaged as AMI, using AMI as server backup for Amazon Elastic Compute Cloud instances, Amazon security group setting for interfaces, launching instances with the same configuration. So I think the answer should be launching instances with the same configuration, selling or sharing software package as an AMI, and also using an AMI as a server backup for Amazon Elastic Compute Cloud instances. So I think this should be the right answer. So yes, you can read here why it is correct. Question number 3. A system administrator must change the instance type of multiple running Amazon Elastic Compute Cloud instances. The instances were launched with a mix of Amazon Elastic Block Storage, Amazon EBS, backed Amazon Machine Images, and instance store backed AMIs. Which method is valid way to change the instance type? So change the instance type of an Amazon EBS backed instance without stopping it. Change the instance type of an image instance store backed instance without stopping it. Stop an Amazon EBS backed instance, change its instance type and start the instance. Stop an instance store backed instance, change its instance type and start the instance. So here we have to note about the answer is that whenever we want to change the instance type, we should note that we have to stop it. We can't do without stopping it. So the correct answer should be either of C and D. But since it's talking about EBS here, so I think the correct answer should be stop an Amazon EBS backed instance. Number 4. A workload requires high read-write access to large local dataset. Which instance type would perform best for this workload? General purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. So the correct answer for this should be memory optimized and storage optimized, as we are working with high read-write access. Number 5. An application requires the media access control, MAC, address of the host Amazon Elastic Compute Cloud, Amazon EC2 instance. The architecture uses an AWS auto-scaling group to dynamically launch and terminate instances. Which way is best for the application to obtain the MAC address? Write the MAC address in the application configuration file of each instance. Include the MAC address in the Amazon Machine Image AMI that is used to launch all the instances in the AWS auto-scaling group. Include the MAC address in a custom AMI for each instance in the AWS auto-scaling group. Use the user data of each instance to access the MAC address through the instance metadata. So the correct answer should be here using the user data. So when we use the user data of each instance, so we get the MAC address there. So we can use the user data. So you can see here why is it correct. Question number 6. A transactional workload on an Amazon Elastic Compute Cloud Amazon EC2 instance performs high amount of frequent read and write operation. Which Amazon Elastic Block Store Amazon EBS volume type is best for this workload? So we want the best type of EBS, right? So HDD answer should be disqualified. And we have two types of SSD, general purpose solid state drive or provisioned IOPS solid state drive. So the correct answer should be provision IOPS solid state drives. So why is that correct? Because we can see here it's optimized for intensive IO operation. So that's why the provision IO SSD is the correct answer. It is possible to create an NFS and it is possible to create an NFS share on an Amazon EBS backed Linux instance by installing and configuring an NFS server on the instance. In this way, multiple Linux systems can share the file system of that instance, which advantage does Amazon Elastic File System EFS provide compared to this solution. So we have to create an NFS, right? So I think the correct answer should be for this is it should be like we should be able to do automatic scaling, and also we can have high availability for this. So Amazon Elastic File System gave the advantage of automatic scaling and then the high availability. So you can see here, like it's a fully managed service, so it's provide high availability. Question number 8. Which feature does Amazon FSx for Windows File Server provide? Fully managed Windows File Server, Microsoft Active Directory Server, backed up solution for on-premise Windows File Server, Amazon Management Agent for Windows File Server. So for this, the correct answer should be fully managed Windows File Server. So when we use Amazon FX for Windows, like we get this fully managed Windows File Server. So you can see here, why is it? Which description of Amazon Elastic Compute Cloud EC2 pricing options are correct? So we need to learn about the pricing option here. On-demand instances enable you to pay for compute capacity by usage time with no long-term commitment. Reserved instances are physical servers that are reserved exclusively for use. Saving plans are budgeting tools that helps you manage Amazon EC2 cost. Dedicated hosts are servers that are dedicated to one purpose, such as firewall. Spot instances offer spare compute capacity at discounted price and can be interrupted. So the correct answer should be like on-demand instances enable you to pay, like whenever we are paying by usage, whatever we use we pay that. And then spot instances offers spare compute capacity at discounted price and can be interrupted. So whenever we require something, we can use a spot instance. So I think this should be the correct answer. So with on-demand instance, you can pay for compute capacity based on our usage. Also, by using spot instance, we can achieve cost saving due to discounted price. So this is the reason why on-demand instances and spot instances is the correct answer, right? Question number 10. A company has 3 high-performance computing instances that must communicate with each other. The company would like to achieve maximum network performance between the instances. The most important requirement is that these systems do not share the same rack. Which placement strategies should they use? So we have spread, we have partition, we have cluster, and we have default. So in default, so they are in the same rack. Even if we are using cluster, ultimately they belong to the same. They are connected to the rack. If one of it fails, then the other will also fail. Even the partition, it still live in the same rack. So the correct answer should be spread. So you can see why spread is the correct answer. The spread placement strategy ensures that the instances are placed in separate hardware racks, each with its own network and provides power source. So this minimizes the risk of correlated hardware failures. So this way we are able to score 100%. We are able to answer 10 out of 10. So I hope you were also able to answer 10 out of 10. If you face any problem in this solving these questions, please leave a comment in the comment section below, and hope to see you in another video. Thank you.